Think about your favorite guitar solo for a second. That big epic moment.
Hmm.
It's never just a simple, clean guitar sound, is it? It's massive, it's roaring, or maybe it's super funky.
Right. And that entire universe of sound, that doesn't just, come out of the guitar by itself.
Not at all.
It's created by these electronic devices that actually manipulate the electrical signal that's coming right off the strings.
Exactly. And that's what we're going to unpack today. The science behind how musicians get those signature sounds. We're talking about guitar effects.
We are. And these little boxes, usually they're pedals on the floor, have these complex circuits inside them. Understanding them is it's a really cool hands-on way to see physics and electronics in action.
Okay, so let's get into it. And I think we have to start where rock music itself really started,
By breaking the rules.
by breaking the rules.
Yeah.
And the big one is a concept called clipping the sound wave.
Yeah. So if you plug a guitar straight into a clean amp, the sound wave it produces looks like a nice, smooth, rolling hill, sine wave.
Very clean, very pure.
But when you kick on an overdrive or a distortion pedal, you're basically forcing an electrical signal that is way stronger than the circuit can handle.
And when that signal is too strong, what happens?
It just gets flattened. We call it clipping. So instead of that nice rounded peak, the signal hits a ceiling and just gets chopped off flat.
And that sharp, flat edge, that's the sound.
That's the grit. That's the crunch, the roar. That is the sound of rock and metal.
So what's the difference then between, say, overdrive and distortion?
Well, overdrive is the gentler version. It's designed to sound like an old tube amp being pushed just a little too hard.
Huh.
So the clipping is softer, a bit rounder.
A warmer sound,
Yeah.
like for blues or classic rock.
Exactly. But if you want to get way more intense, you move to distortion. That's aggressive. It hard clips the signal almost instantly.
Which gives you that really thick, saturated sound you hear in metal.
Yeah, and on both pedals, there's a gain knob that just controls how much of the wave gets clipped. More gain means a more aggressive sound.
And clipping does something else really important, right? It makes the note last longer.
It does. It increases the sustain. Because the volume is being boosted and the wave is flattened, the note just rings out for a much longer time before it fades away.
That's how lead guitarists can hold one single note for what feels like an eternity.
Yep. Now, if overdrive is aggressive,
Then fuzz is just total anarchy.
it really is. Fuzz is an older effect. And the funny thing is, the first fuzz sounds were accidents.
From like a broken speaker or something.
Yeah, a faulty mixing board, a ripped speaker cone. Musicians heard that sound, loved how broken it was, and then engineers had to figure out how to recreate it on purpose.
So how does it work? What's it doing to that wave?
Fuzz is such extreme clipping that it totally transforms the sound wave from that rolling hill into a perfect square wave.
A square wave. So not even a flat top, just
Yeah.
sharp right angles.
Exactly. And that shape is what gives fuzz its thick, woolly, almost synthetic texture. It's just this massive wall of sound.
You hear that all over 60s psychedelic rock.
Oh, yeah. And what's interesting is that a lot of those old fuzz pedals use these very specific parts, germanium or silicon transistors.
And they're really sensitive.
Super sensitive. In fact, even with the fuzz pedal on full, you can often just turn the volume knob down on your guitar and the sound will clean up dramatically. It's like a secret control.
That's a great tip. Okay, so we've made the sound aggressive. Let's totally shift gears now and talk about making it sound epic and vast.
We're talking about manipulating time and space.
Which brings us to delay and echo.
Right. And this is pretty simple physics, really. The pedal records the signal from your guitar, and then it plays it back after a specific amount of time. You get an echo.
And you can be really precise with that timing, down to the millisecond.
You have to be. So you can set the delay time to match the tempo of the song so the echoes fall right on the beat.
This is how some players make one guitar sound like a whole rhythmic pattern.
It is. And you're controlling two main things. The delay time and then the feedback, which is just how many times the echo repeats before it fades out.
And there are different flavors of delay, too.
Two main types. Digital delay gives you a perfect, clean copy of the original note every time.
But analog delay is different.
It is. It's warmer. With each repeat, the sound gets a little darker, a little more degraded. It creates this beautiful, hazy fade that's amazing for ambient sounds.
Okay, so delay gives you distinct echoes. What about reverb?
Reverb is like the next level up. It simulates the natural reflections of sound in a real space, like a room or a giant cathedral. It's not one echo, it's thousands of tiny echoes all bouncing off surfaces at once.
It gives the guitar a sense of place.
It does. And originally, reverb wasn't digital, it was mechanical. Spring reverb literally used metal springs inside an amplifier to create the sound.
And plate reverb used a huge sheet of metal.
A giant sheet of metal, and it's so important for recording. Without it, a guitar sounds really dry.
Like it's just sitting on top of the music instead of being in the room with everything else.
Exactly. It helps it blend in and sound natural.
All right, so we've built our core tone, we've given it some atmosphere. Now let's add some movement and texture.
Now we're in the world of modulation. This is where things get shimmery and swirly.
Starting with chorus, that sound is just so 80s.
It is the sound of the 80s. So what a chorus pedal does is it takes your original signal and then it adds a copy that's slightly delayed and also slightly pitch shifted. It's constantly wobbling in pitch.
And that's what creates that shimmering, lush sound. It makes one guitar sound like a whole section of them.
Yep. And you control it with a depth knob for how much the pitch wobbles and a rate knob for how fast it wobbles.
Then you have things like flangers and phasers, which create those whooshing jet plane sounds.
Right. And they work by manipulating the phase of the sound wave. They essentially shift the timing of a copied wave, which causes certain frequencies to cancel out and others to get boosted.
It's what creates that signature sweeping sound.
It is. But the modulation effect that requires the most, physical work from the player.
It has to be the wah-wah pedal.
The wah pedal, yeah, because you're actively controlling it with your foot on that rocking plate.
It's the one pedal that makes it look like you're trying to squash something while you play. So what is it doing scientifically?
It's acting as a spectral filter. So think of the sound spectrum from low to high frequencies. The wah is like a moving peak, a spotlight.
So when you push your PO down,
You're shining that spotlight on the high, sharp, bright frequencies. When you rock your heel back, you're pointing it at the low, muffled, macy frequencies.
and rocking it back and forth sweeps that spotlight across the whole range.
And that motion mimics the human voice saying, wah! That's why it's so expressive and why it's a staple in funk music. Inside, there's a component called an inductor that's key to creating that vocal-like sound.
And what about tremolo and vibrato? People always mix those two up.
They do. It's simple, though. Tremolo is a change in volume. It rapidly turns the volume up and down, giving you a pulsing, stuttering sound. Think surf rock.
Okay, tremolo is volume, so vibrato is.
Vibrato is a change in pitch. It makes the notes wobble up and down in pitch, creating a shaky quality, like a singer holding a long note.
And both of them just help a long, sustained note sound more interesting and dynamic.
That's the goal.
All right, let's move on to effects that are more about controlling the performance itself. We're talking dynamics and pitch.
Right, and let's start with a really subtle but powerful one, the compression pedal.
What does a compressor actually do?
It limits your dynamic range. That's the difference between your loudest notes and your quietest notes. It automatically turns down the loud peaks and boosts the quiet parts.
So it makes everything the same volume. Doesn't that sound kind of boring?
That's a great question. You'd think so, but the goal isn't to be boring, it's to be consistent and controlled. The result is a really polished sound that cuts through a mix.
Okay, so it helps you be heard in a loud band.
And it makes the guitar feel more responsive. For certain styles, like country chicken pickin', you need every note to pop with the same percussive attack. Compression is the secret to that sound. Plus, it also adds a lot of sustain.
A lot of pros just leave it on all the time, don't they?
Many do, yeah, just to smooth everything out.
Okay, now for the pure digital magic. Pitch shifters and octavers.
This is where we're just completely changing the frequency of the notes being played. An octaver specifically adds notes 1 or even 2 octaves above or below your original note.
So you can make a regular 6-string guitar sound like a 12-string.
Or add a sub-octave and it sounds like there's a bass guitar playing along with you.
That adds so much weight to a heavy riff.
A ton of weight. And the newer ones are polyphonic, which means they can track and shift full chords without glitching out. It lets you create these really cool, synthetic, futuristic sounds.
Okay, so we have all these amazing tools. But a huge part of getting a great sound isn't just what pedals you have. It's how you hook them all up.
Yes, the system itself. So first, these pedals are built to be tough, housed in metal boxes you can step on. They usually run on a 9-volt power supply.
And using a good, isolated power supply is super important to avoid unwanted hum and noise.
Crucial. Then there's the switch. True bypass means when the pedal is off, your signal goes straight through, totally untouched.
It stays pure.
But a buffered pedal keeps the circuit active just a little bit, which actually helps push your signal through really long cables without losing high-frequency clarity.
But the big one, the thing that really separates the pros, is the signal chain order.
Absolutely. The sequence you connect your pedals in fundamentally changes the final sound. It's not a suggestion, it's physics.
So there's a right way to do it.
There's a standard logical way. It's like an assembly line. First up, always, is your tuner.
Makes sense.
Then come your dynamic and filter effects, like a compressor or a wah. They need that clean, pure signal from your guitar to react properly to your playing.
After that, you shape your core tone. So that's your overdrive and distortion.
Right. Get your main grit sound dialed in. Then, after the distortion, you add your modulation effects, your chorus, your phaser. They tend to sound better after the dirt.
And what's dead last?
Always dead last are your time-based effects, your delay and your reverb. This is the non-negotiable rule for a clean sound.
And why is that order so critical?
Well, think about what happens if you break the rule. Let's say you put a reverb pedal before your distortion pedal.
Uh-oh.
Yeah. The distortion pedal is now going to amplify and clip all those thousands of tiny reverb echoes. It turns a beautiful atmosphere into just a wall of messy, chaotic noise.
A mess. It sounds like a mess.
It is. Or if you put a wah pedal after a delay, you're not just applying the wah to your original note, you're applying it to every single echo too. It just becomes confusing. The assembly line has to be logical.
So knowing the signal chain is just as important as knowing what the pedals do in the first place?
It's how you go from just collecting pedals to actually engineering a sound that's completely your own. It's your signature, built with physics.
A great sound comes from knowing not just what the pedals do, but where they go. We hope this helps you start experimenting to find your own tone. Good luck with your studies.